When systems of equations are solved graphically, we search for points common to both lines. Here we have two linear equations. Graphing the first equation results in the green line shown. Second equation is our second line shown in red, and the common point for this particular system is the point of intersection, or the coordinates 2, 5, that satisfy both of these statements. To solve a system of inequalities graphically, we again look for points common to both graphs. This is accomplished by graphing each inequality and determining where the graphs overlap or intersect. So we'll take this first linear inequality, perhaps graphing it by its intercepts or converting it into slope-intercept form. We will graph the line. We're graphing the line using a solid line since this associated equation is included in our solution set. We want values that make this true, and a test value, for example, 0, 0, shows that we do have a true expression, which means we're going to shade on the lower half plane of this boundary line. We'll repeat the procedure to graph the second linear inequality. Here we've plotted the intercepts, and drawing the associated equation, we have it here as a solid line to indicate we are including the points that make up this line, again, as with the first linear inequality, because of having the equal along with our inequality statement. Picking a test value, we can pick the origin again and find that 0, 0 also gives us a true statement, which means we are going to shade above this boundary line. The solution set of this system of linear inequalities is the region shaded bright green, and the bright green is a result of the intersection between the green half plane solution set for the first inequality and this tan yellowish region or half plane that was the solution set of the second linear inequality, and we're looking for the solution set to both of these linear inequalities. To verify this, we can pick a point from this region. For example, if we have the point 1, 2, testing it in the first linear inequality, replacing x with 1 and y with 2, we have a true statement. And likewise, if we use that point 1, 2 in the second linear inequality, we also see that we have a true statement. This bright yellow shaded region bounded by this portion of our first linear inequality, including the points making up that line, along with this boundary line, is also included in our solution set.